Welcome back, everyone. Your instructor, Dr. Rodriguez, here with the ladder logic programming class that we have enjoyed so far. And we're actually diving into lecture number 4. Not much protocol here other than say, in our last lecture, we discussed the idea of relay logic. And here we're presenting to you a number of elements which we call standard symbols to represent relay logic. And we said before, and we'll say it again, relay logic really is a stepping stone to ladder logic. Why is that? Because most electricians will design a relay logic schematic diagram before the system can be automated to become a fully automated system where a control component like the PLC we're talking about is going to be incorporated. So in this table, I have 3 columns. One is what we call manually operated. These are not the only one elements. There might be more, but these are the basic ones. We have the manually operated, we have the automatically operated, and we have the relay control devices. In the manually operated devices, you might have different kinds of types, but this will be the 3 typical ones. You have an emergency stop, you have a normal stop, and you have a normal start. That'll be manually operated components. In the automatically operated, you can have a flavor of normally open or normally closed, a flow switch, which is a type of switch that controls or monitors the flow. Normally open, normally closed temperature switch, which is one that takes care of temperature changes. Normally open, normally closed level switch, which is one that measures the level of liquid in a container. Normally open, normally closed pressure switch, which controls or monitors pressure of any kind. And then we have what we call limit switches. That's similar, sometimes called mechanical limit switch. It's another type of switch that can be normally open, normally closed. And then we have the normally open, normally closed proximity switch. And again, these are some of the basics. There might be a variety of these that you will encounter in real life applications. In the other hand, we have relay control. All right, relay control. And in that area, we can mention auxiliary contact relays. These are not necessarily isolated input elements, but they will be some type that will depend on a bigger control relay. We're going to get into that as we move forward. You also have a solenoid, which we mentioned before, a way to control the passage of liquids or air or pressure in a piping system, electronic control. We have pilot lamp indicators. There could be many of those color pilot lamps. And then we have the control relay per se, a electromechanical system to control multiple IOs. And then we have motors, which is one of the most universally used type of control devices or outputs. This could also be categorized under outputs, except for the auxiliary that sometimes could do both functions, input and output, mainly input. But solenoid lamps, control relays, and motors could always be outputs. So those are manually, automatically, and relay control devices. Right? Let me get up my recording here to bring up something. Here are some of the typical symbols that you might have to represent these devices we're talking about. Notice that we have a mushroom type symbol here. Sometimes you'll even find a little bubble right here. All right, so here we are, and I'm trying to show you here what the standard symbol looks like for the different types of devices. Here we have on the left hand side emergency stop. Notice that it's got a head, mushroom head here, and notice that the contacts are tied to the horizontal bars. That is because it's a normally closed, a little bit of different way to represent a normally closed emergency stop. This one is a normally closed emergency stop. And why do we have 2 types of normal stop? Well, systems typically will have 2 stops, one e-stop and one normal stop. They are both represented with red color. And then we have a normal start, which is normally open. Notice that the horizontal bars are open from the next parallel horizontal bar. So that's typically the way you're going to find them represented. All right, on the right hand side, I have auxiliary contact. This will be a normally open. Let me see if I can bring up a way to scribble around it. So this will be a normally open, right? And this will be a normally closed. Those are auxiliary contact, and they're auxiliary because they depend essentially from either a motor contactor or a control relay. Here's the control relay. We also have the solenoid, which is typically either a box or a circle with a sort of a triangle thing in the center. And then we have the pilot lamp, which is indicated by this. Sometimes you'll have a label with a character, meaning the color of the light, such as, could be an R for red, right? Could be a Y for yellow, and so on and so forth. Then we have the control relay, CR, and then we have the symbol for motor. So in a typical schematic, you will have the possibility of this kind of symbols or very similar symbols. Let me see if I can bring up the symbols for the automatically operated sensors or transducers. If I may, let's see, I should be able to, give me 1 second here, bring that up from somewhere else. So I think we're back again online. Yes, we are. And here I have this time the various symbols that you will encounter, see if this works, in the various automatically operated systems. Notice that we have normally open ones, the ones on top, and then we have normally closed ones. And so in this case we have a level switch, a level sensor, a level transducer. The one on top is normally open. You can actually see that it's normally open, right? The contacts are open. And this one is normally closed. Then you have a pressure sensor or switch, normally open on top, normally closed down here. You have a flow switch. Actually, in this case, the reverse, right? This will be a normally closed, and that will be normally open. We have a temperature switch, normally closed, normally open. We have limit switches, regular switch. We have electronic limit switches, which this could be the transducer type that, again, they could be either capacitive or inductive type. And then we have a speed type switch with various contacts, some of them closed, some of them open. This is for multiple speeds. Notice that it's got F and R, meaning forward and reverse, and the ability to not just rotate or change direction, but also the ability to change the speed. So these are all the various symbols that can be utilized to represent different kinds of contacts in different electrical schematics. This is going to make more sense to you as we dig in deeper into this idea of relay schematic and how it's tied to ladder logic, because in reality you will have great opportunities if you're a plant engineer, plant personnel, maintenance personnel, to do what they call retrofitting. And retrofitting is basically taking a conventionally controlled machine, electromechanical machine, and adding on a automatic control to the machine. And for that purpose, you will either have a electrical schematic or relay logic schematic that will be the basis for you to convert that into a automated process using a PLC controller or similar kind of device. And if ladder logic is the solution, then you're going to go with that. So that's the good reason why we're introducing here the concept of ladder relay schematic so that we can connect with relay logic. So once again, I'm going to bring up my previous screen, all right, so that we can see what, let's see, what we studied so far. Normally operated switches, emergency, normally closed, stop, normally closed, normal start, and then the various normally open, normally closed flow switches to control the flow of a liquid, temperature to monitor temperatures, level to control the level of liquids, pressure to monitor the pressure, limit switch for something that has application to where you want to limit the action of certain operation, and so limit switch will be there to do that. Proximity switch, and then we got the relay control types, solenoids, pilot lamps, control relay, and motors. So once again, it's a good way to understand relay schematic, so you can get a hold of the idea of ladder logic, which is the whole idea of this. All right, I thank you for your time. If you need, you can go back and review this information so it makes more sense to you. But as we move forward, things will come to place, and hopefully they're going to make more sense to you. This is fun to understand electromechanical automated control systems, and if you're in that area, I guarantee you there'll be opportunities for you to apply this knowledge and become creative and do more with that. So for you, your instructor, Oscar Rodriguez. See you next time.